Okay, guys, let's get back. So we're on now, page 8. We've got 1B.3 and 1B.4, and we're looking at logarithms in base E. Okay, so we have lowercase e is what we call Euler's number, and it's spelled E-U-L-E-R. So Leonhard Euler, he's a mathematician, a German mathematician. And he developed E, and E is a little bit like pi in that we call it a transcendental number. It has an infinite number of decimal places. Its value is approximately 2.72, okay? Its physical significance is not heaps important to us. There I've written the formula for how it's derived, and I've got a cool video I can share on how we can arrive at it. But for now, all we're really doing is dealing with it as a number. E, when you see it, is just a number. E is 2.72. And so then we have the log in base of E. That's what we're going to be dealing with, and we call this the natural logarithm. That is ln. All right? So if we have log of E of, let's just put x there, or ln of x, they mean the same thing. ln, logarithm natural, of x, it means the log in base E, in the base of 2.72. So that's the extension we're moving into today. So has everyone seen the number E before? Yep, excellent, okay, good. So the same rules apply, and so that's what we're going to do. We're just going to make our way through the problems, getting a bit of exposure to the rules here. So the first one we've got is ln of E to the 2.2. So the first rule we're going to be using is highlighted at the bottom. If we have ln e to the x, it simplifies to x. Similarly, if you have log in base 10 of 10 to the power of x, that simplifies to x. Therefore, if you have ln, the log in base e of e to the power of x, it will also simplify to x. So if we have ln e to the 2.2, it simplifies to 2.2. All right. If we have ln e to the x on 4, it's going to simplify to x on 4. Okay, next we have ln e to the x on the square root of e. We need to express it as a single power of e. So, using index laws, we have e to the x on top of e to the half. We can do the top power, take the bottom power. E to the x, take a half. We can't collect those. You could write them over the same denominator, but it's not going to help you evaluate it. We've expressed it as a single power of e. The solution is x take a half. Okay, then we're going to use the second part of the shaded area, which is if we have e to the power of ln x. So it's just written a little bit differently. The way we get rid of e is we ln both sides. The way we get rid of ln is we put e to the power of both sides. So e to the power of ln4 evaluates to 4. Okay, e to the power of ln x evaluates to x. Here we can't process it straight away because we have this number 2 out the front, right? But one of the laws of logarithms is that if there's a number out the front of a logarithm, we can make it power. So the first step here is to make that e to the power of ln3 squared, which is e to the power of ln9, which is 9. Sorry. So you notice here I'm doing it in heaps of steps, right? I'm doing it in heaps of steps just to really demonstrate the link between each successive operation. Okay, on to F, we've got ln e to the a times e to the b. We need to express it as a single power of e. So we'll collect them together. That's going to be a plus b. When you have the same base, multiplying the same base, you add the powers together. And so then it's going to simplify to a plus b. We've expressed it all as a single power of e. Okay, next we're on to some logarithmic equations. We have ln x equals 2. Now it tells us what to do. Solve the following exactly for x by applying e to both sides. So when we have ln x and we want to get rid of it, we need to apply e to both sides. Remember, with an equation, you can do anything you want as long as you maintain balance. You have to do it to both sides. It's like a set of scales. You can add 1,000 here, you have to add 1,000 here to keep it balanced. What we're doing is, because these are equal, we're going to put e to the power of both sides. They obviously have to be equal as well. E is just a number. We're putting both sides e to the power of both sides. Okay? And then, well, e to the ln x, what does that simplify to? X. We've solved for x, and we've solved it what we call exactly. It's exact because this allows for every possible decimal place. All right? You can put it in your calculator and evaluate it to 3 significant figures, but we are asked to leave the answer in exact form. Right, clear some space on this board. Now over here, maybe I can just point this out quickly as well. If you want to put logarithms in your calculator, particularly in a different base, like you've got the base 10 button, you just press log, you notice there's an ln and an e to the x button. But if you want logarithms in base A, this is the process in run map, so you just in run map, you press option, you press calc, you press the across arrow, and that's going to bring up the log AB button. So either scribble that one down, or I'll leave it up for now, you can write it down in the section. Okay, let's move on to B. We have 3, take 4 ln x equals 1. Now we're solving for x. Straight away, we can't just add e to both sides straight away. We need to break it down. We want to isolate ln x by itself, and then we can e both sides. So we're trying to isolate ln x. So the first thing I'm going to do is get rid of this 3. All right, I've got an equation. I want to take away 3 here, so I have to take away 3 here. Right, that's what we're doing with an equation. So I'm just going to write this out really, really slowly, just to really show the operations that are going on. So we have 3, take 4 ln x, I'm going to leave a space, equals 1. So I'm going to take 3 and take 3 from both sides. We're maintaining balance. We perform the same operation on both sides. And then look what happens here. We have 3 and take away 3. That's going to cancel. All right, so what are we left with? We've got minus 4 ln x equals 1 take 3 minus 2. You can see we're breaking it down. We're slowly getting ln x by itself. Now, here we have minus 4 times ln x. All right, so if we want to get rid of minus 4 times, we're going to divide both sides by minus 4. All right, divide by minus 4, divide by minus 4. Here I have minus 4 at the top and bottom, so that's going to cancel. All right, and I'm left with ln x equals minus 2 divided by minus 4 is positive half. How do we get x by itself? We have ln x, we're going to put e to the power of both sides. E to the ln x equals e to the half, so we're still maintaining that equality. And e to the ln x simplifies to x. Alright, so we broke that down to isolate ln x, and then we get rid of the ln x to solve for x. Okay, we have ln of x squared equals 5. So this is for C. Alright, 2 ways we can go about this one. 2 ways. I might demonstrate both to show you that they arrive at the same answer. The first thing is, when we have this number, we could treat that as a power. So we could bring it out the front. We could have 2 ln x equals 5. We could divide both sides by 2. So we have ln x is 5 on 2. How do we get rid of ln x? We raise e to the power of both sides. And so we'll have x is e to the 5 on 2. So that's the first way. Yeah, that's right. Yeah. But then the second way is in this step. All right. So I'm going from here to the next step. We can just put e to the power of both sides straight away. So we would have e to the ln x squared equals e to the power of 5. This is going to simplify to x squared. How do we get rid of x squared? We square root both sides. Alright, so we're going to have x equals the square root of e to the, that means e to the 5 to the power of a half, e to the 5 over 2. Okay, so you can arrive at the solution using different processes. Either of those is totally acceptable. Alright, let's move on to D. Unless there's any questions, please stop me. Alright, D, we've got ln 3x squared, take ln x equals ln 4. Alright, so we want to solve this logarithmic equation. We're going to collect these, okay? Remember, if we have ln A take ln B, we can express that as ln of A on B. Alright, so that's my first step. Three x squared on x is going to simplify to ln of 3x. Now from here you can think about it two ways again. How do we get rid of ln? We put e to the power of both sides, so you could carry out that process. Or you can say, if we have log of 3x and it's equal to log of 4, well therefore 3x equals 4. It has to be true. Alright? It's just like if you have the square root of x equals the square root of 64, well x has to equal 8. Alright, so here we have log of 3x equals log of 4, therefore 3x has to equal 4, and we get x is 4 over 3. Okay, then we on to some exponential equations. So I've got a couple of strategies I like to do for these ones. We have 16 to the power of x take 5 times 4 to the power of x equals 0. This is an exponential equation because we have an exponential there and we have one here. Now what we want to do is we want to try and factorise one of the exponentials out the front. And it's not immediately obvious what we can factorise. Apart from, we can express this as a power of 4, can't we? So I'm going to do this in a series of steps again. This is 4 to the power of 2. Alright, and never guys, let's just make this really clear, 5 times 4 to the x does not equal 20 to the power of x. Alright, you think bed mass, we do brackets first, then we do exponents. So the exponent takes precedence over the product. You cannot shove the 5 in it. That is not a true statement. So that's why I'm writing it very clearly like this. Okay, now here we have 2 times x, right? When we think of index laws, if we have a to the n to the power of n, that's equal to a to the m times n. Now, here's something revolutionary. Order of multiplication doesn't matter, okay? 2 times 3 is the same as 3 times 2. M times n is the same as n times n. So similarly here, if we're multiplying them, what does it simplify to? 4 to the 2 times x. Alright, the order of multiplication doesn't matter. So we have 4 to the x squared, take 5 times 4 to the x. Okay? The order of multiplication doesn't matter, so we can write 2 after. We have 4 to the x squared, and here we have 5 lots of 4 to the x. So now you can see 4 to the x is the common factor. That's what I'm going to pull out the front. Even before I do that though, I'm going to show you a little trick I like to do, particularly when you get the quadratic versions of these. They can get a little bit challenging, is if we do something like this. Let a equal 4 to the x. Let a equal 4 to the x. And now let's rewrite this statement here. If a is 4 to the x, well we have a squared. Alright, that's just a squared. Take away 5, take away 5a. I mean, how easy is that to solve? A is a common factor. We pull a out the front. We have a take 5 equals 0. So we've factorised a take 5 equals 0, and then we apply the null factor law. Either a is 0 or a take 5 is 0. Okay. Now, that's only useful if it helps you to factorise, because a still is some value. So we do need to put it back in once we have factorised it. So I have 4 to the x is 0, or 4 to the x is 5. All right, I moved the 5 over the other side. A take 5 is 0, so 4 to the x take 5 is 0. Move the 5 over. Now, an exponential will, by itself, will never equal 0. This has no solution. And we do have that written down in exponential functions. A to the x never equals 0. 4 to the x equals 0. A to the x will never equal 0. No solution. So then we're looking at the 4 to the x is 5, and we need to obtain a solution there. 4 to the x is 5. What we're going to do is we're going to log both sides. Okay? So I'm going to put ln 4 to the x equals ln 5. We're still maintaining that equality. And now, remember that trick where we can move the power down the front. So we're going to have x ln 4 equals ln 5. Alright, that means x times ln 4. ln 4 is a number. You can put it in your calculator and evaluate it. So we're going to divide both sides by ln 4. That'll cancel on this side. We have x is equal to ln 5 on top of ln 4. So that was quite a long one. So I hope you have enough space there to crack that out. Yeah, so this little trick here, it can just be helpful if you can't see what's the factorisation that needs to occur, particularly when we get to some quadratic ones. Okay, we've got some E problems to solve. We've got 7 minutes to get it done. All right, e to the x is 2. That's going to be a. So we have 5 take 3, e to the x is 1. Okay, so we saw just before, if we have ln x equals some number, we put e to the power of both sides. Here we have e to the x equals 2. How do we get rid of e to the x? We ln both sides. We find the natural logarithm of both sides. Okay, so if both sides are equal, then obviously the natural logarithm of both sides will also be equal. And ln e to the x simplifies to x. All right, ln e to the x is x. Okay, next we have 5 take 3 e to the x equals 1. We need to get e to the x by itself. So we're going to break it down until we have e by itself. First step, we're going to subtract 5 from both sides. So 1 take 5 will be minus 4. And then we're going to divide both sides by minus 3. So we've broken it down, we've got e to the x by itself. How do we get rid of e to the x? ln both sides. And ln is 4 on 3, is some number, infinite number of decimal places. Here we've expressed the solution in exact form. Okay. Here, we don't need to simplify it straight away because we've got e to the power by itself. We will need to process it a bit in a moment. So our very first step is to ln both sides. We have ln e to the 2x take 3 equals ln of 11. And this is going to simplify to that whole power because that whole thing there is the power. Alright, so let's make a quick link. If you have ln e to the x is x, here we have ln e to the 2x take 3. That whole thing is the variable, so that's what it simplifies to. And now it's a linear equation, right? ln is 11 is a number, we're just trying to get x by itself. Add 3 to both sides. And then divide it by 2. Don't make that ln 14, okay? Because it's ln of 11, which is a number, and then plus 3. All right, D. Okay, a couple ways we can go about this one. What we want to do whenever we're solving an equation really is we want to get the variables on one side. The variables on one side, the solution on the other. And so we can do anything as long as we do it to both sides, right? So straight away, I'm going to try and eliminate this variable by multiplying both sides by e to the x. Okay? Then what we got is e to the x at the top, e to the x at the bottom. That cancels. All right? Here, this is going to collect to e to the power of 2 lots of x. Remember, we add those powers together. So we're bringing in those index laws, equals 9. Now we can ln both sides. Oof. All right, we got one more. We can do it. Okay, so it's an exponential equation. It's not in terms of e. That's okay. We're going to break it down to get the variable by itself. First, divide by 2. 0.6 to the power of x is going to equal 5. Divide both sides by 2. Next, perform the natural logarithm of both sides. We'll move the x out the front. And ln 6 is just a number. So we'll divide both sides by it. Okay, so we're getting a little bit tricky towards the end there. Alright, so I wrote down for today's lesson 1B.3 and 4, all of 1B. So I would like you to try and have a go at that for homework, see how much you can finish off. There will be an opportunity to ask questions tomorrow. Tomorrow we're only going through 1C, so that's going to be the only one that we're looking at as such. So, cool, good work. Try your luck, 1B. Good luck.